Trebuchet by Matthew Allen, Parker Lanman, Connor Schaefer, and Will Stuckert. Problem definition. The goal of this project was to design and build a working and efficient trebuchet. The trebuchet had to fit inside of a 1 foot by 1 foot by 1 foot box. You were able to take your trebuchet apart in order to fit in the box. You were also required to take the trebuchet out of the box and fully assemble it in 2 minutes.
The design process. The first thing we focused on is a simple design that we would be able to finish on time. We decided on 2 triangles with a bolt at the top used as a fulcrum. Some of the details that really help the functionality of the trebuchet are the fact that we used a bolt rather than a wooden dowel as the fulcrum because the metal would have less friction with the balsa wood arm, and it would be easy to assemble and disassemble. Originally, we were planning on using a 6-pound weight, but using the trebuchet simulator, we figured out that as we lowered the weight, the efficiency went up, so we lowered the weight to 500 grams. Having a long throwing arm and a short counterweight arm really helped increase the distance while keeping the weight low using leverage. One of the problems we faced was the release mechanism. So I went online to look for different release mechanisms used in trebuchets. The most common one I found was a ring and peg release mechanism. It uses tension and centrifugal force to release the payload at the optimal time. And finally, the plywood we decided to use for the triangular sides was very thin, so we decided to double up, gluing 2 layers of the plywood together for each side to keep the trebuchet stable.
Come this way.
The efficiency of our trebuchet turned out quite well. With a ratio of 5004.72 to 5300, the efficiency came out to be 0.944. This was a big step up in comparison to our original numeric model, which had an efficiency of 0.271. The changes that were made from the original numeric model were, we went with the bigger marble instead of the smaller one. We went from a 2,721.55 gram counterweight to just a 500 gram counterweight. While the maximum range was decreased by lowering the weight of the counterweight, the efficiency skyrocketed. The performance of our trebuchet went okay on the first day of testing, with the marble being launched around 4 yards. However, the second day of testing went much better, with the marble being launched 7 yards. This improvement came about as a result of the modifications that we made after the first day of testing. We modified the release mechanism by shortening the fishing line used as the sling, as well as making the pouch cradle the marble better, resulting in a better release angle. The second modification that we made was putting 4 500-gram counterweights on each corner of the base of the trebuchet to reduce movement. Without these weights, it did a slight jump as the marble was being launched. This allowed energy to be lost. Adding the weights prevented the energy from being launched, resulting in a farther range. A performance aspect that worked well was that our counterweight was secured on the arm with duct tape. This reduced the total movement of the counterweight, increasing efficiency. A performance aspect that did not work well was the release pouch. While we improved it on the second day of testing, it could have been more consistent than it turned out to be. As we had several 7-yard launches, we had many failed launches in between. Also, an aspect that worked well was that we had a sanded area at the front of the base, which allowed the pouch containing the marble to transition smoothly from the turf onto the base to eventually being launched. Some design changes that could have been improved in the trebuchet include having the weights on the corners of the base to begin with, as well as a shorter sling. Some construction changes that we could have made to improve the trebuchet include constructing a better pouch to improve the consistency of the launches, as well as constructing a more consistent release mechanism by finding the optimal length for the pin in the mechanism, as we had to change it many times over the course of launching. Overall, the trebuchet could have turned out better, but we were happy with how it performed, and we felt that the work we did accurately was reflected in the performance. Thank you.